not responding right now, so she might not join, as you also said the same thing. So let's start with the class. I think it's wasteful to wait for her. I think from the next class onwards, she'll be able to join on Sunday. If required, we'll share the recordings with her, and let's continue now. Okay, because if she has to join, I think she'll join in a few minutes. But since she has told you also that she'll not be joining, so let's begin. See, we started with Pvt law in the last class, so you don't need to write anything. We'll first discuss few things, and then you can copy down the things. We have discussed that Pvt law is basically mu naught ideal sine theta by 4 pi r square. Now, from here, if we write down the values of mu naught was equal to 4 pi into 10 to the power minus 7. That was the permeability constant. When is your exam, Kutsia?
Ma'am, it's most probably from 20th October. We have not yet been given the official notice, though.
Okay. So right now, official notice has not come. In the
No,
school,
ma'am.
chapter 1 to chapter 7 are over.
Yes, ma'am.
So yes, we didn't practice any numericals from this. We just saw the sign convention, that is outwards and inwards, these things we saw. So this is a question from your NCERT. Let's discuss this. It says calculate the magnetic field at the point P. I think, Kutsia, you have written it only, direction part?
Yes, ma'am.
Okay. Let's discuss this NCERT question. See, here the wire has been given on the x-axis. How do we know this? Because you can directly see the current 10 ampere is flowing across the x-axis. And then this point P is situated at a distance of 10 meters. Now, delta L is a very small length that has been given as 0.001 meter. And since this point P is lying on the y-axis, this will definitely be perpendicular on its own also, even if I don't give this angle. Note all these things are already mentioned in the picture. Now, magnetic field at point P, we have to use the Biot-Savart law. That is mu naught I dl sine theta by 4 pi r square. Now see, all the values that we will put. Mu naught by 4 pi is 10 to the power minus 7 into current is 10 ampere. DL, this small length, is 0.01. 0.01 actually. Delta L, this is 0.01. Okay, and then this is sine 90 degree over here present. Divided by 4 pi we already considered under this mu naught part. And then r square is there, that is 10 whole square. So see, we'll be left with 10 to the power minus 7 into 10 into 10 to the power minus 3 into 10 to the power minus 2. So what do we get? Minus 10, minus 12, minus 11. So magnetic field will basically be 10 to the power minus 11. But see, in the last class, we saw the directional part also, how to calculate the direction. So see, if the current is moving towards the x-axis, so we'll take our right hand towards the x-axis. Where is the point present? Point P is present upwards, above. So I'll curl the finger upwards. Thumb is pointing outwards, that is towards me, right? That is z-axis, because upwards is y-axis, rightwards is x-axis. So this is z-axis, which is k cap Tesla. This is how we'll write the answer. Got it?
Yes, ma'am.
Anything you want to ask in this?
No, ma'am.
Note it down, then I'll tell you one more thing based on this formula. Please write it.
All done, ma'am.
Okay. See, we know current is equal to I, which is dq over dt, rate of change of. So when we put the Biot-Savart formula, B is equal to mu naught I dl sine theta divided by 4 pi r square. When you put in the value of current, so B is equal to C. This is mu naught by 4 pi. DL is there. Instead of I am writing dq over dt. Naught by 4 pi into dq over dt. So mu naught by 4 pi I dl sine theta by r square. Okay, I've put it in the value of. Now see, can you tell them one thing, Kutsia? What is dl over dt? dl over dt. Can you think of anything?
Electric
Length. What?
field.
No. Length by time, 11th class. 11th class recall karo. Length, something length was whenever length gets changed with time. Distance by velocity.
Yes, ma'am.
If you want, you can replace just in case if a question comes. For that, I'm telling you. Most probably, these kinds of questions do not come in the exam, usual biot formulas, but in case if it comes. So this is dq into v sine theta divided by 4 pi small r square. Now see, a, b, whenever you have a, b sine theta, this is equal to a cross b. Okay. B is equal to C mu naught is there. dq cross V by dq cross V by 4 pi r square. So in case if you don't have the charge and the length, if you don't have the current and the length, you can use the charge and the velocity. This is the charge. This is the velocity. Like this. So this is not very important, but just in case if it comes. One more thing I'll tell you. See, when we talk about the Biot-Savart laws application, there are majorly two bases on which it is classified. One is for all the kinds of straight wires we'll be calculating, and another one is for the circular wires. In the magnetic field due to straight wires, there are three cases actually. One is when the wire is infinitely long. When the wire is infinitely long. Second is when the wire is semi-infinite. Okay. Third is finite wire. Now see Kutsia, from this only infinite long wire and semi-infinite long wire are there, and that too just the formula. You don't have any derivation from it. Okay, from the straight wire. You should just know so that when you sit to study, you know what you all have to focus on. For the circular wire, first one is in the if the figure given is a circle, direct circle. So there are two possibilities here. If you calculate it at the center of a circle, second is axis of the circle. Then you have second one as a semicircle. Last is for any circular arc. This is for any circular loop, you can say circular arc, you can say. All the three have the derivations, all the three are there in the syllabus. So circular we will be doing. It is not difficult, but this much we have to cover. Okay, so am I clear? Kutsia?
Yes, yes, ma'am.
Okay, please copy it till here.
Done, ma'am. Done, ma'am. Done, ma'am.
Okay. As I told you, for infinite and semi-infinite, we'll be just discussing the formula part. Infinite means a wire is very long. Okay, this is very lengthy. It extends up to infinity. Okay. So a wire is very, very lengthy. Now, lengthy in the sense means a length that you are not able to measure. If let's say this is a wire, this is extending up to infinity, this edge is extending up to infinity, this much of length. Okay. Now see, point will be lying in the middle. The whole entire wire is infinite and a point will be lying in the middle of it over here. Okay. So magnetic field will be mu naught I by 2 by A. This is the formula. You don't have to derive it. Just remember the formula. Rule is the same. The right hand thumb rule that we've studied for straight wire, it is valid for the infinite wire also. And one more point was here that sometimes the infinitely long wire, they are just written as long wire or very long wires. So for that, don't be confused. It means it is referring to infinity. Second, we have point is put and the wire is semi-infinite. Okay, means this is the wire, this is the edge which is fixed. So at this point, we have the point, which where we have to calculate the magnetic field. The other end is extending up to infinity. Okay, this other end, this is extending up to infinity. This edge which is present. Here we have taken our point of calculation. So magnetic field will be mu naught I by 4 pi. Remember two things here. One is that the wire is semi-infinite. Semi means half. Half of the wire will be infinite and half of the wire will be finite. Now the point of calculation will always lie near the finite end. I'll just show you the lines also. Yes. Point lies near one end. Now in both the cases, if you notice, magnetic field is inversely proportional to the distance. So here, what you get a hyperbolic graph. You get a hyperbolic graph. Because they are inversely proportional. Whenever two things are inversely proportional, y is inversely proportional to x, you get a hyperbolic graph. So that's why this is. Okay, you write down these and we'll practice few numericals from this. Please start.
Yes, ma'am. Done, ma'am. Done, ma'am.
All right. So see, let's say this is a wire. Okay, and this wire, this is one wire that is given to us. 3 points are present. Okay, so don't write. Let us just discuss first. Then I'll give you time to copy. 3 points are here. This is point A. This is point B. This is point C. And in this question, it's a mixed question. Actually, this is not a question from your board exam. It's just a generated question, but just for us to practice values. So 3 points are given. This is the first point where the point is present and assuming the wire is infinitely long. Second is the B point, which lies on the axis of it. Third is the semi-infinite wire, which is lying at a distance of 2 meters. All the distances are of 2 meters only, but first point is infinite, second point is lying on the axis, third is the semi-infinite wire. Now, magnetic field at a point. This will be equal to mu naught. Now, look, infinite wire. What's the formula puts here for an infinite wire?
Mu naught I by 2 pi a.
Very good. Mu naught I by 2 pi a. So mu naught is 4 pi into 10 to the power minus 7. Current across this wire is ampere divided by 2 pi into the separation of the wire. This point is 2. So that will be 2. This 2 gets cancelled. This is 10 to the power minus 6. Now let's see the direction. Current is going upwards. Point A is lying on the right. Finger is pointing inwards. That is minus K cap Tesla. Clear?
Yes, ma'am.
Okay. Second says when the point is B. Point is B means, look, this is the wire carrying the current 10 ampere. Point B is present. So point B is lying on the axis of it. So when we use the Biot-Savart law, actually, mu naught I dl sine theta by 4 pi a and all, when we use the actual Biot-Savart law, when you put in the values of angle, it will be 0 degree because the point is lying exactly on the axis of it. This is 0 degree. This point is lying on the axis of it. So magnetic field will be C mu naught I dl sine theta divided 4 pi a square actually. 4 pi r square. Now look, here the value of theta is actually 0 degree. And what is sine 0, Kutsia?
1.
0.
0, 0. Yes.
Okay, so magnetic field will be simply 0. No value of magnetic field will be left. Okay. Third is semi-infinite, as if the C point is there at a distance of 2 meters and this wire is semi-infinite. Now for the semi-infinite wire, what's the formula? Tell me.
Mu 0 I by 4 pi a.
Like mu naught by 4 pi a. Now mu naught is 4 pi into 10 to the power minus 7. Current is 10 divided by, this is 4 pi into A is 2. This gets cancelled. This is 5 into 10 to the power minus 7. Again minus K cap into Tesla. Look, if I write down the direction, in terms, still the point is towards the right, so this thumb will point inwards. Am I clear?
Yes, ma'am.
All right. First, note down this question.
Done, ma'am. Done, ma'am.
Okay, good. So try this question one, then I'll discuss.
Done, ma'am.
Okay, yes. What's your answer?
Ma'am, I should do this question or should I just copy the question?
Try it once by yourself, because I think now then we'll start with the circular one. No, so just try it once by yourself.
Okay.
Then I'll discuss it. Okay.
Okay, ma'am. Ma'am, should we subtract the magnetic field from the
Let
right
me
and
discuss it. You stop writing now. Okay. I'll discuss it. Then you match the steps wherever you were able to do, or if something was incorrect. Okay.
Okay, ma'am.
Now look, this is an infinitely long wire, and this is the point P that is present. Both the wires are infinitely long. So we just have the first case. Right? Both the wires are infinitely long. See, the point P is lying in the center. Current is moving upwards, and the wire is extending up to infinity. Now, look here. For the first wire, the magnetic field will be mu naught I by 2 pi A. But where will be the direction? See, this is the current moving upwards, fingers getting curled, thumb is pointing inwards. That is, this is inwards, minus k cap also you can write inwards also. Basically, this is going in, like this is the magnetic field. Okay. Second magnetic field will be, due to this wire, will be mu naught 2I divided by 2 pi A. Now see, current is flowing upwards, but the point is lying on the right side. Sorry, on the left side. So curl the fingers, thumb is pointing outwards this time. This is pointing outwards. Outwards means plus k cap you write, or this will be actually pointing outwards like this. See, two vectors in the opposite direction. Definitely we'll have to subtract it. Correct? And this one is greater. So see, the net magnetic field will be mu naught to mu naught I by 2 pi A minus mu naught I by 2 pi A, which will be outwards, this much of whole thing, k cap. So when you subtract these, you will get mu naught I by 2 pi A, and from here 2 minus 1 k cap. So this is equal to, the net magnetic field is equal to mu naught I by 2 pi A, k cap for the direction, Tesla for the unit. This is how we'll write the final answer. Clear?
Ma'am, why did we write 2 mu naught I by 2 pi A?
Because current here given is 2. Here only I was there. Okay?
Yes, ma'am. Yes, ma'am.
Please write down the solution. Then we'll move on to circle.
Done, ma'am.
Okay, let's come to the derivation for the circularity. See, first let me discuss the derivation of magnetic field at the center of a circular loop. Now understand this properly, consciously. This is as if we have a circle. Let's say we have a circle over here. whose radius is capital. Okay. The radius of the circle is capital R. Now we take a very small portion for our calculation purpose. In the sense, we'll just take a small length dl. Okay, dl will be there, which is a very small length that is taken. And what is exactly this dl? This dl is actually our current element that is present. Okay, so we just have a circular wire of radius capital R is there, and dl is a small portion that we have taken. Now, why did we consider this dl? What was the need of considering this dl? Reason is that, Kutsi, when you have a small length dl, you can modify it for any of the values that are missing. If I want, I can calculate the magnetic field using it. If I want, I can calculate the current using it. So very small value. If you integrate it, you will get the entire length present. Whatever quantity you are calculating over the length, that will be calculated itself. So this is what DL is. Now, current that is flowing through the circuit, is I. Let's say the current that flows through the circuit is I. Now, magnetic field according to Biot-Savart law will be dB is equal to mu naught I dl sine theta by 4 pi r square. So here, angle between, look, if you look carefully, the angle between the current element and the position vector, that is 90 degree. This angle formed is 90 degree. So see, this will be magnetic field will be mu naught I by 4 pi r square integrating it from dl. Okay, a small portion dl has been taken and we are integrating this. Now see, here B is equal to mu naught I by 4 pi r square is it. I have taken capital R, no? So here also I'll take this as small. Now see, tell me one thing. If I have a very small length DL and I added multiple times DL plus DL plus DL plus DL like this, if I keep on adding it, DL plus DL plus DL like this, basically I'm integrating it. So what will I get at the end? If I'll add all the DLs that are present on the circle, what do you think I should obtain? Hmm? If all the current elements in this circuit, in this wire, are added, then what should be the figure obtained? See, let's say if you add all the length, it will give you the length of the circle back. So integral of dl will be 2 pi r, which is the length of the circle, into 2 pi r. R will be cancelled. 2 pi will give you 2. The magnetic field at the center of a circular loop is mu naught I by 2 r. Let's say n number of turns are present. Let's not consider one turn. Let's say n number of turns are present. Then you will simply have to multiply it with n. Magnetic field will be mu naught I n by 2. Am I clear till here? What's there?
Yes, ma'am.
Okay. Write it, then we discuss the direction.
Ma'am.
Yes, stay.
Ma'am, actually, there is some work. I have to go out with my father now, actually.
Okay. So when do you have to leave?
Now only.
Okay. All right. Right now? Just right now?
Yes, ma'am.
Okay then. So I think your next class will be on Sunday. So Sunday morning, let's complete this then before you go to the school.
Okay, ma'am.
Okay.